Welcome to Internet Quality Academy. The channel is for the quality control engineer, site engineer, and the civil engineer who are working in the construction field. In this channel, we are dealing with anything and everything which is required to get success in the construction. Today also, I'm going to discuss about a very important topics of the construction, that is concrete batch slip checkpoint. So what is the normal procedure that the concrete has coming from the RMC supplier, and when the RMC supplier send the concrete, they have sent along with the batch slips. Now we need to check the batch slips very carefully in order to ensure the quality parameters of our concrete. So today we are going to discuss each and every point, what to check and what not to check, everything. And if you're new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So without wasting time, let's jump into the subject, the checkpoint of concrete batch report. So what is the normal procedure? That we need to do the first design mix, then we need to do the trial mix, and when the trial mix is as per the design mix, we said that the grade is approved. Suppose we are doing M40 grade of concrete design mix and then trial mix, and we are getting the parameter as per our target strength and everything. So we are finalizing the for the projects M40 grade will be there. So the type of cement, what is the mineral admixture, what is the chemical admixture, what is the coarse aggregate percent, what is the fine aggregate, what is the water cement ratio, that all everything will be in the design mix. Now it is finalized. Now we have ordered the concrete whenever actual performance is happening. Now the RMC supplier has sent the concrete is the site. Now it's our time to check the quality parameter. So in the design mix, what is we have done, that is all quality assurance part. Now the when the actual performance or actual concreting to be done at the site, and the RMC supplier has sent the concrete, now it is to be the quality control part. So what is the quality control part and what is the checkpoint? Let one by one. First, we need to check the batch number. Why batch number? Because this will be very particularly identify the batch or the concrete. So ensure the traceability of the batch and helps in tracking quality in case of any issues. Now, if we are not checking the batch number and we are randomly using the concrete, then if there is any problem in the quality of the concrete, we cannot find out which batch is the problem. So that is why the batch number is very much important. So why will get the batch number? Here we can check from one example. See here, it is the DC number, or it is saying it is that number that we can say batch number. Sometimes it's called DC number. Here you can say DC number 2201749. This is the unique number. It is not actually, it is with other batch number. It is the unique one. And for that car, we can find out that this batch number is from this car and from this batching plant and everything. And where we are pouring that one, that also we need to mention in our quality control checkpoint. The second is the date and time of batching. So it is very much important to check the time and check the date. Confirms when the concrete was batched to ensure it is used within the recommended time frame, typically 90 to 100 minutes from batching. It's a typical, but this retention is up to 4 hours, 5 hours also is there as per the mixed design. But why it is checked? Because suppose a concrete has batched at the batching plant at 4 o'clock. Now it is a transit time from batching plant to the site. It is coming at a 5 o'clock. It may be taking some 1 hour. So now we have, if it is within 2 hours, we have to pour the concrete. We have only 60 minutes to pour the concrete. So accordingly, we need to plan that from the batching point time to the pouring time should be what is the retention time that should be done within the time. That is why it is important to know the what is the date and the batching time. The next is a mixed design reference. So it is very much important that check the mixed design code or the designation, that is M20, M50. Suppose there is another problem also that maybe you have M40 grade of concrete. There are different mixed proportion of cement and GGBS or cement and fly ash. Maybe it is 60-40, 60% cement 40% GGS, or 50-50 cement or 50% GGS. That also you need to check the when the batch slip is coming. Maybe you order M40 50-50 ratio, that means 50% cement and 50% GGBS. So whenever the batch slip you are receiving, now we need to check whether the same mix and the same mix ratio has been sent or not. If it is, you order for M40 50-50, but they are sending M40 66 60-40. So you, in order to get that one, you also need to check that one. Then the mix design reference. Then we need to check the quantity of concrete. It is very much important to check the quantity. Suppose you have ordered 6 cubic meter, now they have sent 5 cubic meter. That has to verify whether they are giving the right quantity or not. Verify the quantity of concrete supplied, usually in cubic meter, to ensure it matches the ordered quantity. Sometimes it is need to wait the verify the quantity, that is called the yield of the concrete. So that is why it is not every batch, but randomly also you need to check what is the weight. We all know the weight of the concrete, and if it is 5 kilometers, suppose my density is 2400. So if it is 3 cubic meter of concrete, we need to know that 200 7200 kgs. That means 7.2 ton should be weight. But if we are not getting 7.2 ton, that means there is a problem in the quantity. So not only the cubic meter quantity, you need to verify the weight also in random basis. Then we need to check water cement ratio. See, it is a very much important. So what is the water cement ratio? Maybe my water cement ratio in 0.39 or 0.36, whatever. Cross check and water cement ratio to ensure the desired strength and workability of the concrete mix. If the water cement ratio has changed, which means my entire design has changed. If the water cement less or the more, that means the water percentage is not as per the requirement. So we will not get that desired strength. Durability will be a problem. So that is why it is very much important to check the water cement ratio whenever you are receiving the concrete from the batching plant. Then admixture use. So what type of admixture use? There are different types of admixture. Is this the retarder, super plasticizer, plasticizer, air entrant? So what type of admixture is specified in your mix design? That has to check. But if you want to know about the admixture, I have made a detailed video. Link is there or in the description. Please check and you will get full information about the admixture. But now, if your admixture is super plasticizer, or maybe from the rock, or from the ECAMS, or from the Sika, whatever, that you need to verify that the right kind of admixture is used or not. The next is slum value. So it is their workability. Now, whatever they are sending the concrete from the batching plant, they are checking and they have given the initial slum value. So what is initial slum value? That also you need to check in the batching plant, because it is mentioned. Suppose your requirement is 120 plus minus 25 or 120 plus minus 20. So you need to check in that batch slip that whether this is mentioned or not. That also you need to verify. I will show you one batch slip and you will find out these things easily. Then what is my point is aggregate details. What is the aggregate? The size and proportion of the aggregate. What is the maximum size of aggregate? Maybe 20 mm, maybe 10 mm. So you need to check that the maximum size of aggregate is used or not, and the proportion. What is the quantity? And that quantity has to verify with the mixed design quantity. Then it is coming another point, that is cement type and quantity. So what is the cement types we are using? That is OPC, PPC, that you need to verify into the mix design and along with the concrete batch slip, that the right kind of cement they are sending. Then it is coming batching plant details. So from which batching plant it is coming, the name and the location of the batching plant should be checked for verification and traceability. See, here is a two catchment. First point is that maybe the RMC supplier has 5-6 batching plant, but whenever you are taking the approval or they have given the proposal from the 4 batching plant, the other 2 they have not given. Now whenever they are supplying from the that 2 batching plant, that means this is not approved. So this has to check that whatever the approved batching plant, from that only it should come, and the location, name and location, why, in the verification and traceability. So it is should be checked that this batching plant is is as proved by us, and it is already checked, and the quality control parameter is all okay for the batching plant. That is why we're given approval to supply the concrete. That is why you need to check that whatever the batching plant we choose or whatever the batching plant is approved, the material has coming from that batching plant only. The next is truck details. So check the truck number and driver's name for record keeping and logistic taking tracking. So why? Suppose in the batch slip there is the truck number is there and the driver number is there, but who has bring that truck, that truck number is separate. That means it has interchange. Maybe this truck has the different types of concrete. So we would not use that one. So we need to check the truck number in the batch slip, and we need to verify physically the truck number, so that if it is matching, then only we can allow for the concrete. The next one is temperature of concrete. That is also, we know that concrete temperature should be recorded on the batch slip, especially in extreme weather condition, to ensure is within acceptable limits. So whenever it is coming, that temperature should be maintained or maintained. Then transit time, already we discussed that ensure the time taken during the transit from the plant to the site is within acceptable limit. That already we given, that if, what is the transit time plus the pouring time, it should be whatever is my retention time, maybe 2 hours, 3 hours, that should be within the time. The next is moisture content in aggregate. It is very much important to know the moisture content, because if your design is in the SSD condition, so whenever you are adding water into the mix, the aggregate will absorb the moisture. So you need to calculate that moisture percentage. Or if it is a rainy weather, or moisture already is there in the coarse aggregate and the fine aggregate, then you need to correct it, the moisture part, because if we are not corrected, then the mix will be the more water, and if the more water, the strength will be reduced, or we will not get the right kind of moisture. So that is why moisture content of aggregate is very much important, and that has to check whenever it is arriving at the site into the batch slip. So these are all the point we need to check. Now we'll see one sample. See here already whatever we discuss, one by one we will show you. First, see the DC number. Okay, this is the batch number. And what is this material description? M40 Dura Plus. Type of cement, OPC. Minimum cement aggregate, this cubic meter. Maximum size of aggregate 20. Some flow, as this also mentioned. See, some flow is 125 plus minus 25. Batch time and date at 18/8/2024, 432. Pour structure slab, water cement ratio, and then cumulative quantity, how much we order. And then here it is CA 12 mm, CA 20 mm, then the coarse aggregate 12 mm, coarse aggregate 20 mm, fine aggregate MS means manufactured sand, then water, C1, C2, C1 is cement, C2 is supplementary cementitious material, SCM, here it is in GGBS, and then admixture, plus is the admixture and this total. So what is the quantity? That we need to 440. See, this 440 we need to check whether as per our mix design or not. The CA2 665 we need to verify with the mix design. FM 750, water 750. Now in the water, see here is the moisture correction. They are adding in 16.86 because it's a SSD condition, and whenever they are adding water, the aggregate will absorb that is why they are adding, and it is coming 166. So these the things you need to check each, and see here is chemical admixture type 9103, mineral admixture type as per 456, the slump flow is as per IS 4926. So these are all things you need to check. Here also you need to check the truck number. I'm showing. This is also you need to check, that is name of the person received RMC. So who is receiving that one, that also need to check here. Then the truck number, say the tax invoice number, quantity, the truck number, this is the truck number, then signature of the receiver and rubber stamp of the firm. So whenever you are receiving and whenever you are verifying each and every details, if you find it as per the requirement, then you have to sign and you have to stamp this one, so that it's completed all together. So these are the things you need to check whenever The batch slip is come to the site. I hope you find it useful, and if you find it useful, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notifications. And I'm waiting for your valuable comments, so that from your valuable comment, everybody will be benefited. And if you want to know anything more about quality control and construction, please let me know. I will come with more content like this. And thank you once again for watching me.